Hello everyone, we are RGA Tutorials, and in today's lesson we're going to be learning about atomic structure. Okay, we can start. Alright, so now all matter is composed of atoms, and what are atoms? Atoms are the smallest part of an element that can take part in a chemical reaction. So now all atoms are made up of mostly empty space around a very small, dense nucleus. Alright.
They're made up of empty space around a very tiny, small nucleus. And the nucleus is dense. And what does it contain? It contains protons and neutrons. Now, the nucleus has a positive overall charge. So we have the protons here, let's just say the color blue, then the neutrons here, the color red. Now, we said that the nucleus has an overall positive charge. Now, why would this be so? Because the protons in blue here, they've got a positive charge, while the neutrons here have a neutral charge. So overall, positive plus neutral makes positive. So the nucleus is going to be positive, right? And then we've got negatively charged electrons right here, the black dots right here. Negatively charged electrons, they're found in orbitals in the empty space around the nucleus. So we say electrons orbit the nucleus of the atom. All right. So now, this is just a bit of a diagram. So here we've got the protons, which are positively charged, the neutrons, which are neutral, and then the electrons, which are negatively charged. So overall, the atom is going to be neutral. Now, why is the atom going to be neutral? Because the nucleus is positively charged because of the protons. The electrons are negatively charged, and they're found in orbit around the nucleus. So positive plus negative makes neutral. All right. Now, onto the subatomic particles of an atom. So now the protons, now they are positively charged, right? Electrons are negatively charged, neutrons are neutral. So now all of these subatomic particles here, they are so small that it's not even possible to measure their masses and charges using conventional units such as grams or coulombs. So now instead their masses and charges, they're compared to each other. And so they're called relative atomic masses, like you've heard, or maybe you haven't heard, that's all right as well, or relative atomic charges. Now, these are not actual charges and masses, but charges and masses of particles relative to each other. So let's say now their charges and masses in comparison. So protons and electrons, they've got relative atomic charges. So basically, their charges are made in comparison to one another. So a proton is positively charged compared to an electron, which is negatively charged. An electron is negatively charged compared to a neutron, which is neutral. So now, protons and neutrons, they've got a similar mass, all right? So each one is assigned a relative mass of around the number 1. So like you've seen, or probably you haven't, if you haven't started your AS level course yet. Electrons, they've got 1,836 times smaller mass than a proton and a neutron. So I'll just show you a table. Okay, like here. We said they've got a 1,836 like figure of mass smaller than protons and neutrons. And so their mass is often described as negligible. So now let's go over the relative charges since we've gone over the relative masses. So for a proton, the relative charge is going to be +1. A neutron, the relative charge is going to be 0 because remember we said it's neutral. And for an electron, its relative charge is going to be -1. Okay, just a quick exam tip. So you can see from the table that the relative mass of an electron right here, the relative mass, is almost negligible like we've just said. So now the charge of an electron is going to be -1.602 times 10 raised to the power -19 coulombs. Whereas the charge of a proton up here is positive 1.602 times 10 minus 19 coulombs. So like we said, the relative mass of a proton is, well, we call it the relative mass because it's relative. The mass is relative in comparison to the mass of an electron. Okay, on to some key terms of atoms. This is just a denotation. We'll get back to this in a bit. But now the atomic number here, which is shown as a denotation Z, the atomic number is basically the number of protons in the nucleus of an atom. And so it has the symbol Z like we can see here. So now the atomic number is also equal to the number of electrons present in a neutral atom of an element. So like we said, protons make the nucleus positively charged, while electrons orbit in their negative charge around the nucleus of an atom. So protons, which are positively charged, and electrons, which are negatively charged, make for a neutral atom. So in a neutral atom, the number of protons is going to be equal to the number of electrons. So for example, let's say the atomic number of lithium is 3. So the neutral lithium atom has 3 protons and therefore also has 3 electrons. So now the mass number, which is shown in a denotation here as A, the mass number or nucleon number is going to be the total number of protons plus neutrons in the nucleus of an atom, and it's got the symbol A like we've just seen right here. So now the number of neutrons can be calculated by the mass number, which is A, subtracting the atomic number, which is the number of protons, and then we get the number of neutrons. Okay, just to preface, protons and neutrons, they're also called nucleons. So now why they're called nucleons, this is because they are found in the nucleus of the atom. Okay, on to masses, charges, and subatomic particles. So now the mass of an atom is concentrated in the nucleus. So the mass of the atom, this is the full atom right here. In the middle here, we've got the dense nucleus, which contains nucleons, protons, and neutrons. So now the mass of the atom is going to be concentrated at the nucleus. Okay? So now because the nucleus contains the heaviest subatomic particles, that is the protons and the neutrons, the mass of the electron is negligible. Like we said, the relative mass of an electron is 1 over 1,836. And that is basically slim to negligible. That's why we said if it's in charges, it's minus 1.602 times 10 raised to the power minus 19 coulombs. Okay, so now the nucleus is positively charged, like we've said, due to the protons. And so electrons orbit the nucleus of the atom, contributing very little to its overall mass. Because we said, like we said previously, the mass of the electron is negligible. So it creates like a cloud of negative charge, the electron does. So now the electrostatic attraction between the positive nucleus right here and the negatively charged electrons in orbit around that nucleus is what holds the atom together. Okay, now we're going to go over behavior of subatomic particles in an electric field. So now protons, neutrons, and electrons, they all behave differently when they move at the same velocity. So that is the speed in an electric field, like we can see right here. Okay, so when a beam of electrons is a beam of electrons, or let's just say a beam of particles. This is a beam of particles right here. So these are the electrons, these are the neutrons, and these are the protons. When a beam of electrons right here is fired through, or let's say fired past the electrically charged plate, so the positively charged plate over here and the negatively charged plate over here, the electron is going to be attracted to the positively charged plate, because we can see like this beam of electrons right here is attracted to the positively charged plate, right? And why is this? Because negatively charged electrons are attracted to a positively charged plate. Like charges repel, opposite charges attract. It also shows that electrons have a very small mass as they are easily deflected. So we can see that these beam of electrons right here, or this dotted line, it doesn't even go further down like the beam of neutrons or the beam of protons. It's attracted to the positively charged plate instantly because of how negligible its mass is. So it's very easily deflected. So now onto a beam of protons right here. We know protons are positively charged. So a beam of protons is deflected away from the positive over here, and it's attracted to the negatively charged plate over here. So this proves that the proton is not only positively charged, but the proton is deflected less easily than electrons, and this shows how much heavier in mass protons are than electrons. So now a beam of neutrons, like we see, it just goes straight across. It's not deflected either to the positively charged plate or the negatively charged plate. From this, we can see that a beam of neutrons is neutral in character, so it's not attracted or repelled by the negatively charged or the positively charged plate. Okay, so now on to determining the subatomic structure of atoms and ions. We're going to do a few questions in this bit of the learning video. Okay, so just a few things to go over. So an atom is neutral and has no overall charge if the number of protons and electrons are equal. But now ions, on the other hand, they're formed when an atom gains or loses an electron, causing them to become charged. So the number of subatomic particles in atoms and ions can be determined given the atomic number. And remember what we said, guys, the atomic number is the number of protons in the nucleus, or the mass number. That is the nucleon number, so the number of protons added to the number of nucleons. Okay, now on to protons. So now protons, like we said, the number of protons is the atomic number of an atom, right? And it determines which element it is, basically. So all atoms and ions of the same element, they've got the same number of protons. So for example, in the case of the atom here, lithium has an atomic number of 3, but we can see in its outer shell electrons, it's got 2 outer shell electrons. Why? Because in the first shell, we're going to have one electron right here, then out here they're going to be 2. Okay, so now lithium has 3 protons, whereas beryllium, on the other hand, beryllium has 4 protons actually. So now the number of protons equals not just the atomic number, but also the number of protons of an unknown element. It can be calculated using its mass number. So remember, the mass number is the number of protons plus the neutrons. So to find the number of protons, we do the mass number minus the number of neutrons, and that would give us the number of protons. Okay, now onto a worked example. So maybe you want to pause the video and see if you can work through this question by yourself. But the question is, determine the number of protons of the following ions and atoms. So in the case of Mg2 plus ion, carbon atom, and then an unknown atom of element X, with a mass number of 63 and 34 protons. Okay, remember to pause the video to see if you can answer it by yourself first. All right.